Welcome back. All right, we're going right into example 3. So example 3, we want to find the integral of x squared over 16 minus x to the 6th. So if I look at this one, I'm going to notice that it is going to have a similar format to some of those trig, arc sine, arc cosine, arc tangent things. And so we're going to look at this denominator, and we're going to say, hey, it can be written as 4 squared minus x to the 3rd squared. And so that can give us a clue that, hey, we really have one of those a squared minus x squared things in disguise. So I'm going to let u equal x cubed. So if I let u equal x cubed, then du dx is going to equal 3x squared. So then my dx is going to be du over 3x squared. So now if I go back to my integral, I'm going to have x squared over square root of 16 minus x squared times du over 3x squared. So then I will get 1/3, pull the 1/3 out. My x squareds will cancel, and I will have 1 over square root of 4 squared minus x squared. U squared, I mean. Come on, Joby. There we go. U squared. And then if I look at this, I can see that that is going to be the arc sine. And so then this will just become 1/3 of arc sine of u over 4 plus c, and then go ahead and substitute back in that u value. So now I have 1/3 arc sine of u over 4, x cubed over 4 plus c. Great. Next, this one is 1 over 1 plus e to the x. And so when we're looking at this one, oh my gosh, where's my notes? All right, so when we're looking at this one, what we want is, if we wanted to use a u substitution, we would want e to the x to be able to cancel. So what I'm going to do here is some algebra manipulation. And so on my numerator, I'm going to add e to the x and subtract e to the x. And so how that's helpful is, it is helpful because now I can separate this into 2 separate fractions, 1 plus e to the x over 1 plus e to the x, which is going to be nice and easy. And then my second integral will be negative e to the x over 1 plus e to the x, which is great because then I can use u substitution on that one. So my first integral will just be the integral of dx, and my second integral, I'm going to let u equal e to the x. If you want to let u equal e to the x, you can do it that way, and it helps you out. So du dx equals e to the x. So then when I get this one, I am going to end up with the natural log, if you want. Let's see here. So dx equals du over e to the x. Actually, what I'm going to do, here's what I'm going to do. I'm going to let u equal 1 plus e to the x. There we go. That's how I did it. Du dx equals e to the x. So then dx equals du over e to the x. So then that cancels. So I'm actually just going to end up with 1 over u du after my e to the x's cancel. So then I am just going to end up with x for my first integral minus the natural log of the absolute value of u plus c. And then go ahead and substitute my value back in. So natural log of 1 plus e to the x plus c. Okay. All right, next one. A disguised form of the power rule. So we have this really messy integral, cotangent times natural log of sine x dx. So for this one, what we're going to do is we're going to do some nice, fun u substitution. So if I have u equal to the natural log of sine of x, then when I take the derivative of that, I am going to get the derivative of sine, which is cosine, times the derivative of natural log of whatever, which is 1 over whatever, so 1 over sine of x. So then that means we have our good old friend cotangent here, so du dx equals cotangent of x. So then dx equals du over cotangent, which is fantastic because then that will cancel. So now I have the integral of cotangent of x times u times du over cotangent of x. My cotangents cancel. So now I just have u du, which is going to be u squared divided by 2 plus c. And then I'm going to go ahead and substitute back in my u. So I have 1 over 2 times natural log of sine of x. And all of that gets squared plus c. Oh, come on. There we go. Last example, we are going to find the integral of tangent squared of 2x. And so this one can get a little tricky. So when I look at this, we're going to use the fact that we have, let's see here, solution. We don't have tangent squared listed on our basic trig identities. So the first thing I'm going to do is I'm going to set u equal to 2x. So then I have du dx is going to equal to 2. So dx equals du divided by 2. So now I have that this is the same thing as the integral of 1/2 tangent squared of u du. And we have our trig identities like sine squared plus cosine squared equals 1. We also have that tangent squared is the same thing as secant squared minus 1. So I'm going to use that identity and say, hey, this is the same thing as secant squared of x minus 1 du. Oops, secant u, not x. And then when I look at that, I can go ahead and split that up into two different integrals. So 1/2 the integral of secant squared u du minus 1/2 the integral of du. And then this one is on our, well, it is on our little sheet, but also the derivative of tangent is secant squared. So when I take the antiderivative, I get that this is 1/2 tangent of u minus, and then we have our little good old friend power rule over here, u over 2 plus c. And then go ahead and substitute back in that u value. So I have 1/2 tangent of 2x minus 2x over 2, which is just x, plus c. All right, so here is kind of a list of the different little techniques you might use. So first technique is to expand if we have things, quantities being raised to a power. Another trick is to separate the numerator. We can use completing the square if we need to somehow help us see those arc trig identities. We can use long division for dividing. We can also go ahead and add and subtract things in the numerator to help us make things a little bit easier. We got our good old friend trig identities and multiplying by conjugates, okay? So the Pythagorean conjugates, if you have a plus b on the denominator, multiply both top and bottom by a minus b and see if that helps you. Okay, so these are all different algebra techniques that can help you change your integral into something that is going to be easier to integrate. On your homework, please just try all the problems. If you can't figure out what manipulation is needed, refer to CalcChat, and if you're still confused, totally fine. I don't expect you to do all of them right away.